A survey of 35 hotel rooms in New Orleans found that the average hotel room rate was $88.42. So we're talking about New Orleans here. So my N1 value is 35. My X bar 1 value is 88.42. We go by Phoenix. 50 hotel rooms, average of 80.61. Just marking down what I know. Standard deviations. It says 5.62 or $5.62 and $4.83 respectively. So New Orleans, because it came first, is the 562, which means Phoenix must be the 483. So we're making New Orleans our population 1, and we're making Phoenix our population 2. It's very important that you take note of this, because when I go over here and I do my hypotheses, not going to affect my null a whole lot, because we're talking about mu1 being equal to mu2, but it may very well affect my alternate. In this case, because we're just looking for is there a significant difference, we're looking at mu1 not equal to mu2. So this is the two-sided test. Just like we did with one sample, we're going to cut a little bit off both sides. In this case, since we're talking about a 5% significance, 2.5% on both sides. And we're going to find critical values of negative 1.96 and positive 1.96. Now I define my test statistic. To do that, I find the difference between the two averages, the 88.42 and the 80.61. And I have to find my standard error. To find my standard error, I take my deviation from New Orleans and square it and divide by my sample size. I take my standard deviation from Phoenix, square it, and divide by my sample size. My suggestion would be you do the denominator piece first, unless you're really good with parentheses in your calculator, because there's a lot of chance to make mistakes here. This is going to give me a very, very large z-score of 6.68, which is clearly in my rejection region. So I'm going to reject the null. Since I'm rejecting the null, I'm getting rid of the idea that these two are the same, and we can conclude at 5% significance that there is a significant difference between the New Orleans hotel room price and the Phoenix hotel room price.